Good afternoon to all. Hi, this is Dr. Subi, Program Manager, CITER from Bergen. I'm the responsible person for the events and the training programs that are conducted by CITER. And CITER, Society of IT Professionals and Researchers. We provide you Microsoft accepted training programs, certifications, publications, and researches for IT professionals as well as non-IT professionals. An interesting thing, I can recognize some of our participants from the participants list where they are in our previous webinar. I'm so happy to see you all again to be a part of CITER's journey. And for this time, we are having some of the participants in our CITER's office. You're also welcome to this webinar. And in today's webinar, you can learn how to safely gather data and connect the sensors to the cloud service through simulation activities along with some of the tools. And for that, we are having our brilliant speakers, Rajesh and Dr. Bhraguram. Rajesh RK, he's working as a lecturer at University of Technology and Applied Sciences, Shinas, Sultanate of Oman. He's having an experience of 16 years, and moreover, he had conducted more than 10 workshops and training programs, and he had been conducted more than 7 blogs too. And he's a Cisco certified instructor as well as he's an Hawaii certified instructor in routing and switching. He had been a co-author for the paper Deploying a Smart Academy. Now I'm moving on to our Dr. Bhraguram TM. He's also working as a lecturer in University of Technology and Applied Science, Shinas, Sultanate of Oman, and he's having an experience of 15 years in academic field as well as 1 year in the corporate field also. And he had published more than 19 articles. And another interesting fact is that he's holding more than 3 patents with him. And so once again, I'm welcoming you all to our CITER's webinar. And you all are requested to please mute your microphone and also video sharing. If you have any questions, please feel free to ask, and all your queries will be answered at the end of the sessions. And again, after the sessions, as you all know, we will be providing you a feedback form, and kindly provide all your valuable suggestions to us. And also, we will be providing you the participant certificate to all the attendees soon after you're uploading your feedback forms to us. And so now I'm handovering this session to Rajesh and Dr. Bhraguram. Yes.
Thank you, Ms. Dr. Subi, for the introduction. Thank you, Dr. Saji, for giving us the opportunity. So, we'll share our screen. So, the topic of the workshop is Internet of Things concepts and applications. So, the contents we'll start with basic concepts of IoT, the hardware and software. Then we'll move into Tinkercad and Packet Tracer simulation tool. Then we will move into the Python introduction, then simulation activities, then about orientation for Cisco NetAcad. And the objective of a workshop is understand the basic concepts of IoT. How do we apply the IoT in daily life? And what about the hardware and software tools we use for this tool, or for this IoT? And the introduction to the simulation tools like Tinkercad and Cisco Packet Tracer, and about the Python language concepts, and demonstrating different simulation activities in IoT, and orient the student towards Cisco NetAcad platform. Okay. So the first topic, we'll be giving a brief introduction about why do we use IoT, what is the definition of IoT. So I will hand over to Dr. Bhraguram.
Thank you, Mr. Rajesh. Am I audible? Is it okay? First of all the dignitaries, the organizers, and the students, guests, everybody, great and warm, deep welcome to all of you for this session. I'm Dr. Ram. I'm here with my colleague, Mr. Rajesh, and we are going to present. First of all, I would like to thank the organizers of this seminar, mainly, especially for inviting us for this informative session. And we are trying to present some basic information regarding Internet of Things and Python. And actually, we have planned with some theory content, also with some practical session. I don't know how far we can go for the practical session very deeply, but of course, our time limit is very, very crucial. So I'm planning to give some basic theoretical idea regarding this IoT first. Hope all can cooperate with this one. I'm very happy to see all the participants of this one. And first of all, IoT. So we heard about it. So for the past 5 years, many of us we are hearing about these words IoT and Python. It's called interconnected technological terms. So this session is completely based on Internet of Things and the corresponding programming parts. So Internet of Things, as we know, it's billions of physical objects and the things connected to the internet. We can exchange and collect the information over the devices, and these devices can control a particular environment with its own characteristics. So we know it very well. So the definition, no need, everybody knows the definition of this one, and why we have to go for the IoT, because the today's world, in today's environment, it's very much needed and it's very much interesting to go with Internet of Things. We can if you're going for the applications of Internet of Technology, we can apply it in almost all the latest fields, including you can see the slides as it is mainly for transports and logistics. We can go for utilities, smart cities, smart building. Everywhere we can use it in almost all the industries, all the leading industries we are using Internet of Things. So these are some of the important applications that we have found in Internet. And these are some of the components we have included with IoT. Of course, IoT, we have a separate part for programming part is there, and also as with some hardware-oriented devices also. So these devices, how we are going to connect it and how we are going to participate in the controlling of the particular environment. So this is mainly included in components of IoT. We have many devices, including our day-to-day life, our mobile device, our laptop, our pads, so everything we are using. And of course, we have a special type of sensors and actuators. It's part of the Internet of Technology. And of course, we need some connectivity tools, something like the internet or something like Bluetooth, and all these things we have included. Of course, we have IoT Cloud. It's a part of that. It's very important part of Internet of Things, because whatever the information, whatever the measurements, whatever the controlling information we are trying with the Internet of Things, so we are just simply we can upload it in cloud systems, and later we can use it with cloud system components. So many of the cloud systems are supporting Internet of Things. Mr. Rajesh will give some of the important cloud-related information for you, okay, later. And of course, it's used for analytics and data management purposes by using Internet of Things. Nowadays, many firms, many organizations, so they're using it for analytics and data management purposes. So when we are concentrating on hardware components of Internet of Things, the most important things are sensors. So whatever the things we are measuring, whatever the things we are concentrating, everything we are coming under with sensors. So different types of sensors are available in the market. It's a cheap sensors are available. Of course, some costly sensors are available. So we can use it in our own manner. That's the most important. That flexibility is providing by Internet of Things. So how much flexibility is there for selecting or choosing the sensors? At the same time, we can select whatever the technology is there. We can choose the particular technologies for importing to Internet of Things. So that flexibility is there in this field. So this advanced field, including different types of, as I told, different types of sensors are available in the market. You can go for temperature. Some sensors they have given here. Some chemical sensors are there, some gyroscopes, some optical, gas, accelerometers, light motion. So you can see various types of sensors we are using. By using all these, the measurements can be calculated, whether it's the remote area or in the developed areas also. By connecting all these sensors, we can go for the next level evaluation. And the main important things, apart from the sensors, we have actuators. So converting the electrical energy, we need this component mainly, and the controllers. So which are the different types of controllers used in Internet of Things. Of course, we have some hardware-oriented components, I told you. So all these hardware components are connected through some board-based systems, some Raspberry Pi, some Arduino-based systems we are using. So these type of boards are, of course, we can term it as controllers. These controllers are part of this Internet of Things. And of course, as part of this session, we are trying to use Raspberry Pi. It's a small, low-cost, single-board computer, and some other components are also there, and we are trying to use Arduino also. And the computation is very much easy, and Raspberry Pi is a as I told you, it's a low cost and single board computer, but still it's supporting many of the sensors. It support many of the programming scripts, and also it's supporting many of the controllers. Of course, we have one interconnected breadboard is also there. So this is also one of the important device as part of this session we are trying to use for simulation purposes, and it's connecting sensors and actuators. So it's a temporary connection. We can remove it according to our purposes. So this breadboard is one of the important part. And for experimental purposes, many of the companies, many of the academic institutions, they are using this breadboard. Very easily, we can connect sensors and actuators with this breadboard, and it's highly portable. That is one of the important advantage of this breadboard. And today's world, the Group I board is one of the leading electronic board we are using in IoT, Internet of Things. The main advantage of this one is a plug-and-play system. And this is also an electronic board, and it connects hundreds of different sensors. So how many sensors we are connecting? See, for example, if you're taking any of the systems, like any of the advanced systems, like a full organizational implementation, we have hundreds of sensors. So how we are going to connect all these hundreds of sensors into a particular board? But Group I board is a good electronic board, and we can connect. We can continue with many different sensors. We can, at the same time, we can connect with the Group I board. So Raspberry Pi board and the Group I boards are the most important electronic boards we are using as part of this seminar. And you can see the picture. See, when you're looking at the presentation slide, you can see that different types of sensors. Here on the right side, we have given the Group I board. It's a model they have given here. It's an example they have given here. And different types of sensors like humidity sensor, water sensor, temperature sensor, audio sensor, all these sensors are connected to Group I board. The connection mechanism is very easy, and it is very easily available in the market. It's cheap also. So that's why we are trying to forward with this Group I board. You can easily connect with Raspberry Pi model. So we can go to the next one. Actually, these are the various hardware devices, hardware modules we are using as part of this session. Apart from that, we are going for software tools also. Mr. Rajesh will continue with this one.
Thank you, Dr. Raghuram. So we'll go with the software tool. So first software tool we are going to use is Cisco Packet Tracer. It is a visual simulation tool designed by the Cisco. We can create network topologies, and we can imitate various computer networks. And also we can add IoT components, sensors, everything. So this is the Packet Tracer tool. So I'll first open the Packet Tracer tool in my computer. So this is okay, this is actually the activity. Okay, now this is the Packet Tracer tool. So this is the empty workspace. Okay, so when we are opening Packet Tracer, it will look like empty. So we have so many components. Okay, network devices are being here. So there we can see router, switches, hub, then firewalls, then say wireless network devices. Then we have end devices, yani the device which are used to send and receive data. There we have computer, laptop, server. You can all drag and drop all device. Okay, on the platform. Now this one workspace we can drag and drop. and we have different type of other type of end device like AC. When you are using that IoT based which one activities, we can use the AC air conditioner. Then we have coffee vending machine. We can add a battery. We can add a speaker. We can add a carbon monoxide detector. We can add some door. Then we can add some fan. We can add a garage door. All these components we can add into the Cisco packet as a workspace. Okay, and here also we can have so many devices, okay, which we can use in our IoT environment. It's actually a simulation environment. Whatever we do in the real world now, in the Raspberry Pi board or in the Group Pi board, whatever we are doing there, the same thing we can do in the packet tracer, because now we are doing the which one simulation activity, right? That's why if you are conducting the workshop in real time, means we can show you that Raspberry Pi Group Pi, but as it is a which one webinar, we can show you that which one the simulation tools. Okay, then we have which one board. Okay, as Dr. Bragaram was referring, no, the boards for connecting device, so MCU microcontroller boards and single board computer, these are all simulations or similar like your Raspberry Pi boards. Okay, so then we have connections we have wired cable, okay, copper cable, crossover cable, serial cable. So many cables are used for connecting the devices. Okay, see, all these things are available in our packet tracer tool. This is the first packet simulation tool we are using in our workshop. So Cisco packet tracer 2 is being introduced by the Cisco systems. Okay, they are being providing this tool. So in that tool also we can do all the network simulations as well as IoT based simulation activities. Okay, so that's the first one. Next tool is Tinkercad. This is actually a web-based tool. Okay, so here also we can create so many simulation models. Okay, 3D models, simulations of IoT activities. We can add the code, everything there. And for that, we need to visit tinkercad.com. You have to register an account, then log in with the credentials. Then we can create our own circuit and test the circuit to get the output. Okay, so I will show you how to log into Tinkercad. So I have opened my Tinkercad. I'm opening my Tinkercad account. Okay, so I already have the account. I logged in already, so that's where the dashboard is coming. Okay, so this is Tinkercad. So we go to the designs. Okay, so if I want to create a new circuit, okay, so first I will show you how do we create. Okay, then I will show you the simulation activities. Okay, so we'll go to create. There is 3D design. So design is actually for AutoCAD and design. No, here we go for circuit. Then only we can create the IoT based circuit. So we'll go to the circuit. In that circuit, the same workspace will come, and here we have to check the components. Okay, so what are the components we have here? So we have resistor. Okay, you know the electronic component. Resistor means resist the current flowing into the device. So we can drag and drop a resistor. If you want to change the color of resistor, okay, if you want to change the which one resistance unit, you can do this here. Okay, then LED, light emitting diode, another component. Okay, if you want to change the color, go here, change it yellow. Whatever you want, you can do this. Okay, LED, light emitting. Then we have push button, like it's an input device. When you press this button, okay, we can write a program like when I press the button, LED will be on. So this is push button. Like that, we have so many devices. Potentiometer, it's a variable resistance. So this also we have to change the resistance, means can go here, change the resistance value, say 250, make it 500, like this. Okay, then we have capacitor, again electronic device. Then we have battery. For powering all these components, we need battery. Like that. Now there's next one, like Dr. Bugram was referring, no, breadboard. To connect all these devices, we need breadboard. So this is a breadboard. Okay, then we have what motor. To run a component, we need motor. Again, there is another one, servo motor. There are like that. So many components are available in the Tinkercad platform. Then ultrasonic sensor, I'll tell you one by one. This is a distance sensor. Okay, like that. This is motion sensor. When somebody is moving, okay, this sensor will detect the movement. Okay, and this one, piezo, it will produce the buzzer. Okay, it's produce the buzzer. Okay, it will produce the which one sound. Okay, it's a buzzer, it will produce the sound. Then we have temperature sensor. Okay, this sensor which will read the temperature. So whenever you are doing the IoT activities, sometimes I want to read my room temperature, I want to adjust my AC based on the temperature. So for that I can use the temperature sensor. Okay, like that we have, this is multimeter. It is an electronic device, right? It will show the voltage, the current, amplifier, no, which one? Voltage, current, resistance, everything in this multimeter. Okay, like this, the another one, soil moisture sensor. Okay, I want to check the moisture level of the soil. Say I'm having a farm, okay, in Salala or in India. Okay, I want to sense the moisture level of my soil. Okay, so for those things, I can use moisture sensor. So whatever devices you need, okay, all the sensors, actuators, input device, output device, everything, whatever you see in the real world, we can simulate all the things in the Tinkercad. Okay, then see Arduino board. Okay, as Dr. Bragram was referring, this is the board, Arduino board. It's a controller. In this controller, we are connecting all these sensors, actuators, and we will write the program in Arduino IDE. Then you run the program and we can produce the output. This is the use of your Tinkercad tool. Okay, so we are referring to simulation tool. One is Cisco Packet Tracer tool. This is given by Cisco. Okay, that you can install in your computer. Okay, another one is Tinkercad. As I referred, this is Tinkercad. Okay, this is a web-based tool. You can log in, create an account, log in Tinkercad, then you can do the activities. Okay, now after introduction about the tools, what we have is we are going to start the simulation activities one by one. Okay, so first thing is we are going for which one? Simulation activity in a packet tracer. Okay, so here demonstrate packet tracer activity with IoT registration server and wireless home gateway. Okay, so first one is renewable energy source to power the home appliance and smoke detection project. Okay, I will show you that topology. Okay, so my topology is this one. I'll go to the, okay, this one is the activity for simulation of renewable energy. Okay, for energy power, which one? For turning on the devices and for smoke detection. Okay, so see here we have a network here. Okay, this is a router and this is switch. These are network devices. Okay, into this device I am connecting all the IoT input and output devices. Okay, IoT sensors like smoke detector, then I am connecting a solar panel to have the solar energy, then I am connecting a fan. Okay, then I am connecting a coffee vending machine, I'm connecting a street lamp, then I am connecting a garage door, fire monitor, carbon dioxide detector, window, camera, sprinkler to spray water, then wind turbine, wind detector, and IoT server. Okay, so these are the devices I want to connect to the network, and in the network we need a server. Okay, that server is here, IoT server. Okay, in this server I have enabled IoT service. Okay, so I'll show you the server. So this is server. Where do you enable the service? Okay, this is IoT service. Here I have turned on the IoT service and the username and password also given here. Okay, now how do I register the device? Okay, now I have to register these devices. Now I already registered the devices. How do I register these? So if I go to the solar panel, okay, when I go to the solar panel, just I will show you only one device how I registered. Okay, then you can go through that. Okay, so in the device, go to the configuration. Okay, so here whenever I am connecting any device, I need IP address, right? In the network, IP address is very important. Okay, be it be solar panel, be it be a smoke detector, be it be a, let it be a coffee make machine. Okay, whatever machine we need, if you want to connect to the network, I need IP address, right? So this IP address I am getting from the server via DHCP. So this is the DHCP option we have to enable so that the IP address you will get in each device from the IoT server. Okay, after that what we need is we have to register the device in the IoT server. For that, I have to go to remote server option. Here I am having IoT server. So I am choosing remote server. Then I have to mention the IP address of server, then username and password for IoT service. Okay. Once it is connected, you could see refresh button. It's already connected. Okay. Now what I'm going to do is I want to show you the devices status in the server. Okay. As I told you, all these devices I have connected and I have registered in the IoT server. Okay. So I'll show you the IoT server. When I open the IoT server, see this much devices are connected. Okay, smoke detector. If you want to see the status of smoke detector, okay, so check here the value of the smoke. Now level is 0.27. Now garage door, what's the status? It is on. then fan, what's the status here? So like that, every device and its status we can see in the IoT registration server. Okay, how you are seeing the screen is, I have a option in my registration server. The option is IoT monitor. When I click this option, okay, this is in IoT server. In this server, after register every device, when you go to IoT monitor, when you click the IoT monitor, okay, just let me click. Okay, so when I click the IoT monitor, I could see the list of devices connected. Okay, so let me click that one. Okay, it is already there, but just I closed and open it. Okay, so here when you are opening, no, they will ask you username and password. Okay, so what was the username password I gave? Admin Cisco. What is the IP address here? My IP address here is, let me check my IP address. Okay, my IP address here is 192.168.10.2. Okay, so I have to go here, take the IP address, then I want to go to the IoT monitor, open again, because I'm first time, that's why I'm showing. Okay, so when you're doing it first time, you should know how do you connect. No, that's why. Okay, so it's not responding. Let's wait for a few seconds. Okay, let the server come up. So let the IP address window comes. I will enter the IP address. Okay, in the IoT monitor. So just wait for a few seconds. Okay, because it's first time, so I'm showing you how you start from scratch. Okay, now I'll open this one. Put the IP address of the IoT server. Then username as admin. Password is Cisco. Whatever I registered, same username, password. Then if it is successful, you could see the device listed here. Okay, so just wait. So now we can see the devices listed. Okay, so all the devices which are registered in the IoT server, we can see the device names. Now I put some conditions. Okay, as I told, no, as Dr. Bragram was telling, we want to write the coding, right? So simple coding. What I write is, I'll show you the conditions. Okay, so in the conditions, they will list you what are the conditions we have added. Okay, so here I already added the condition. So first one is, if the wind turbine output is greater than 10 kilowatts. Okay, if the wind turbine of the output of the wind, no, the wind speed is greater than 10, means what happened? No, fan will be high, coffee machine on, and set camera on. Okay, if it is less than 10 kilowatts, right, then fan will be off, coffee vending machine off, then camera will be false off. Okay, like that. Solar panel, see, they will have a solar panel. If the output you are getting is above 50 watts, you will be having the fan high, make the coffee machine on, then camera on. Then panel is having less than 50 watts, means all will be off. Okay, then smoke detector level, so the smoke coming out of the area is greater than 0.2. The garage door will be open, window will be open, fire sprinkler will be started working, and fan will be high. Like that, I put some condition. Now I'm going to test this condition. Okay, how to add condition? There's an add condition. Okay, there's an add button there. Click the add button, then you can add the condition. Okay, so I already added the condition. So if I start adding, it will not, it will take some time. So yes, I already added the condition. Now just showing the testing. So here, what I do is, to produce the smoke. Okay, I have some old car. Okay, so when the old car is started, the smoke is coming out. So what happened? I will check the smoke detector value. Okay, so the smoke detector value here is, when the smoke is high, greater than 0.2, means garage door true, open, then window open, then fire sprinkler open, then fan high. Okay, so here let me go back to this home, and let me check what is the value of the smoke detector. Just go back to the home. Okay, so here smoke detector, the value is already greater than 0.2. So what happens is, see here, the fan is running. Okay, then the garage door open, window open, camera open. Okay, fire sprinkler is on. Okay, so the first condition is done. The next one is, see, solar panel. Okay, the solar panel is high, means, see, output is coming, means coffee vending machine is on. Okay, so greater than 50 means coffee vending machine on, fan is working. Like that, that condition also working. Now what about wind detector? Okay, so wind detector, how do I check wind detector or wind values on or not? I'll go to the server and I will check the wind detector value. Let me check the wind detector value. So wind now 0 kilowatt. So why it is 0 kilowatt? Because I want to make the one more simulation, like I need to make the environment in a night, okay, night mode. So I'll go here, I can change the time, okay, I will make it as a night 12 o'clock so that the wind will be more, okay. So I'll put like the condition, okay. Let me put that one. Okay, I'll go to the environment, okay, environment. Then I will change the timing so that if it is daytime, solar light, okay, the sunlight will be more, so solar panel will be giving more output. But if it is red nighttime, no, wind will be more. So I'll go for and edit the condition here, time, okay. So I'll just edit the timing. Just go here. I'll click the edit, okay. So it takes the simulation, no, little delay. So I'll click the edit button. Okay, that's see one by one the features are coming out, okay. So let me check the edit button. Actually, when you click the edit button, the time will be there, so you have to edit the time, okay. Let me click one more time. So here it is morning 11 o'clock, okay. So what I will do, I have to change this to night, okay, so that the wind will be heavy, so that all the other conditions will be working, okay. Let me check here. So let me click that okay button. Sometimes it takes like little delay, okay. Let's wait. So don't have more time to wait for this, okay. But still one more time I'll try, okay. So this is actually you have to change the time here. If it is night means the wind also will be heavy, okay. So actually it works, okay. The because of this time, the button issue, I'm just closing this, okay. So it will work. Now I'll go for the, this is the first one, okay. Second activity is, so this is done. Now second activity is this one. The second activity is detect movement using motion sensor or motion detector to turn on the home appliances. Okay, like energy conservation, right? Like when someone enter the room, that time only the home appliances will be turned on. Like when you go for a mall, right? If you go to the washroom of a mall, means whenever you are going into and get inside, that time only the lights will be on. Otherwise, it will be off. So what happens is there is also they have implemented IoT. There they have motion sensor. So whenever the motion is detected, then they have programmed like whenever motion detected, all the lights, fan, all that, everything should be that electronic, now home appliance will be turned on. How we can simulate that in the packet tracer? Okay, that I will be showing now. So for that, I will again go back to packet tracer. So I will close this. I'll go for the packet tracer activity in my machine. So motion detection. Let me open it. So this is the activity for motion detection. Okay, as I told you, when someone is entering the room, that time only the fan, the coffee vending machine, the AC, the which one, that camera, window, everything will be on. If nobody is coming to room, no motion detector means all the device will be off. Okay, so let me. This is fast forward button in packet tracer. If you want to turn devices work faster, means you click that fast forward button. Okay, so here this is another device where we are connecting. There's no IoT server. Okay, here we have a wireless home gateway. So in this scenario, I am connecting all IoT devices to the home gateway, which is acting as IoT device wirelessly. Okay, there is no wire. Like earlier, we had switch, router, server, all are connected by wire, and the conditions we write in the server. But here, all devices are connected into home gateway device. That's another type of IoT server device, but there is no wire, only wireless. Okay, so this wireless device has this one, like your Wi-Fi router, we have SSID, password, everything. We have authenticated. No, any device cannot be connected without username and password, right? So here also, all these devices first connected to the Wi-Fi or the home gateway device by using username and password. Okay, already connected that device. Okay, now in my topology we have motion detector. Motion detector means this is a device which will detect or this will read anybody moving inside the room or not. Okay, and this is fan. Then this is coffee vending machine. Then this is which one, window open. There is a camera. This is AC, and we are connecting a tablet. Okay, now this is the home gateway. Just I will show you what is a home gateway. So in home gateway, we have wireless. Okay, this is my wireless setting. My SSID is home gateway. My password is 129. By giving this username password, all these devices connected. Okay, now after showing the settings, what I'm going to do, I'll show you at least one device how they are connected. Okay, I'll go open the coffee vending machine. Okay, then in the configuration, you could see I have connected the wireless device. That's why when I click DHCP, I'm getting IP address automatically from the server. Then as I'm using the IoT server as home gateway, instead of clicking the remote server, I'm clicking home gateway. Okay. If you are connecting remote server as the IoT server, then you have to enter the IP address of server, username, password, blah, blah, blah. Okay. But here, no need that or that things. Okay. We'll go for the home gateway option. Just click the home gateway option. Okay. Now we go for the conditions. Okay. So what are the conditions here? So here we cannot display the conditions in home gateway. Like IoT server, we don't have the IoT monitor here. For that purpose, I connected the tablet PC or tablet device into home gateway. Now, when I go to the tablet device, okay, when I open the tablet device, there is IoT monitor. Instead of IoT server having the tablet monitor, IoT monitor, here the wireless home gateway not have any which one IoT monitor. The tablet connected to home gateway is having IoT monitor. So I'll open the IoT monitor there. When I open that IoT monitor, you can see the conditions, you can see the username, password, what are the devices connected, status, everything here. See here we have connected AC, fan, coffee machine, camera, window, motion detector. This much device I connected. Okay. Now when you go to the status of each device, you can see AC on, then fan, status, every device status I can see. Now go for the condition. When you go for the condition, see if two conditions, okay, if motion detection is true, yani means if the motion is detected, yani AC is on, fan is high, camera on, window on to false, then coffee machine is on. Okay. If it is not detected, all the conditions will be reversed. Okay. Now, how do I test? When you are testing, no, in the real time, you have to press the Alt key in the keyboard. When you press the Alt key in the keyboard, go towards the motion sensor, motion detector, rotate the or scroll the mouse over there, move the mouse over there. Okay, when you move the mouse pointer over there, you can see motion detector. That means the red color is on. That means the conditions for motion detector, like a fan is on, coffee machine is on, then window is closed, then camera is on, then AC is also on. You can see that AC. Now it is off. Now again, I will move the cursor over here, right? We can see that motion detector means the AC is on, means red color. Then fan is working high, running high, then coffee machine is on, then window is closed. When you are releasing the mouse button, see all are off except the window is now open. If someone enter the room, what you will do is so I can even Oman or anywhere, if you're maybe in Norway different, okay, but in Oman or don't know Gulf countries, so whenever someone enters the room, we have to turn on the AC because it is very hot. Okay, so we turn on the AC. When nobody there means we will open the window. That's what, just simulation. Okay, this is the second simulation activity we put in the packet tracer. Okay, so after that, what we do, these are the two activities we put in the packet tracer simple simulation. Then what we do is in the slide we have simulation activity in Tinkercad. So Tinkercad, we have 4 exercises. LPG gas leakage detection using gas sensor project. Okay. Then safe distance alert system using ultrasonic sensor. Then detect movement using PAR motion sensor in a room to turn on fan, light, and buzzer. Then detect a door open or not using flex sensor. Okay. These 4 activities we'll discuss in the Tinkercad. So what is that first one? So in industries or in at home also, we know gas is an important factor, right? So if any gas leakage is happening, okay, ethanol or whatever methanol, whatever gas, okay, LPG, whatever gas is leaked, okay, in our project, no, that gas leak detection will be, okay, we will detect that gas leak, which one, gas leakage using the gas sensor. So whenever the gas is leaked, okay, we have some alarm, we have some display devices, they will show some messages. Okay, so evacuate messages, all the things we can do in the Tinkercad platform. So first one, LPG gas leakage detection system using gas sensor. Okay, for that we have to go to Tinkercad. So I already opened the Tinkercad platform. This is my Tinkercad. Okay, so now I'll open the Tinkercad. There are so many projects we have done. Okay, so where is gas leak detection? But this one is gas leak detection. Okay, I'll go with this one. Let me open that screen. This is gas leak detection. Hope you can see this topology. So as Dr. Abraham was telling, this is a breadboard. So this board is used to connect the devices. See, this is the Arduino board, or we call it as a controller. Okay, I cannot connect all the devices to these pins. So what I will do, I will connect the devices into the breadboard. From breadboard, I will give the connections to the Arduino controller. Okay, so what are the, first of all, I will introduce the devices. This is a breadboard for connecting the sensors and all devices. Okay, then this is the Arduino controller. Here we will be connecting the sensors and actuators, and I will write the program in the Arduino, and we have Arduino IDE. In the real world, we have Arduino IDE. There the programs are called as sketches. Okay, and we will save the program as .ino program. Okay, then we will run the program. Here I am running the simulation tool called as Tinkercad. Okay, in our lab, in our college lab, university lab, we have all real device. In college, we are introducing, we are teaching the students in real device. Okay, Arduino board, then Raspberry Pi board. But as it is a webinar, okay, I cannot show you the real device. So that's why I'm showing in the Tinkercad. Okay, so before coming to class, what the students will do, they will practice the activities in the Tinkercad platform. Their login in their laptop, and when you come to college, they'll have a clear idea, and they will do in the real device. Okay, so this is simulation activity. So first of all, this is breadboard. This is the buzzer which will produce the alarm sound. Okay, if the gas leakage is above a particular limit, this buzzer will produce some sound. Okay, then this is a gas sensor. This gas sensor which will detect the leakage. Okay, and this is LED, light emitting diode. If the gas leakage is above a particular limit, red LED will be glowing. Okay, if the gas leakage is not there, means green LED will be on, right? Then this is a display screen. Okay, LCD display. There we can display the messages. Okay, whether the gas leakage is there, it's an alert message, it's like a alert message or evacuation message. Whatever message is there, the message will be displayed in the screen. Okay, now I connected these devices to the Arduino control. Okay, we have some, which one, cables are connected. Okay, so this one is 5-volt power. Okay, this is ground, and this one is resistors. If you don't connect the resistor, what happens? No, the full current, the electricity will get into the device, and the device get damaged. That's why we, to limit the current flow, we have resistance. Okay, now just I will show you the code first of all. Okay, just a few seconds. Okay, so here I want to mention which pin you are connected each device. Okay, so red LED I connected to second pin. Okay, so I connected the red LED into second pin here. Okay, like that, all the devices are connected. What's the pin number they mentioned? Now sensor, the gas sensor is connected in A0. A0 means analog pin. So I connected that into, see, this is connected to A0, analog pin. So input is read from the analog pin. Okay, see this device through A0. Now the mode of each device, some output. So LED is output device, buzzer is output, sensor is input device. Okay, and the threshold value, the value which you used to compare is 300, because we cannot produce the gas now, right? So gas, that's why we put the sensor value is 300. Okay, then we have the coding. Okay, so I'm reading the value of the sensor by using analog read, and reading the and storing the value into integer variable analog value. Then I'm printing the value. Then if the analog value which I get from the gas sensor is above 300, sensor thresh means the threshold value 300. Okay, if it is above 300 means the message will be printed as gas is high. Then the digital red LED will be high and the green LED low. Then the buzzer will produce a sound. 1500 is a type of voice it is getting, sound it is producing, and this is the time duration of producing the sound. Then now the LCD message will be cleared. Cursor will be set as 0 to 1. Okay, the location, the position of the cursor. Then during that time, so when the gas is high, LCD will show alert message. Then delay is given. Then after that, we have to clear the screen. Then again the LCD will show evacuate message. So after once you get alert, no, all the people inside the factory or the home should evacuate. That's what. Okay, you not wait till the evacuate message will go immediately, right? When the siren on the alarm will rise, right? So else, if the LCD is not leaking, okay, LPG is not leaking means this will be, LED will be green, will be high, red will be low, no buzzer. Okay, no tone buzzer means the buzzer will not produce a sound. Okay, then the message will be safe and all clear. Okay, this is the code we have written. Okay, now we go to perform the simulation. Okay, so initially there is no gas leakage, means it will show which one, safe, everything is safe, no need to worry. Okay, so I just click the start simulation button. When I click the start simulation button, okay, see what happens. Initially there is no gas leakage, it's slicing, safe, all clear. After some time, gas leakage. Now buzzer is producing sound, red LED is now glowing. Now the gas leakage. Now when I click this, I could see gas leaking. Simulation, right? I cannot produce the gas leakage in the real world, right? Then that time I will not be here. I would have been gone. Okay, so that's why I put a simulation here. Okay, so I'll put the simulation like this. Okay, so based on the gas leakage, we can have the messages evacuate, red LED. Okay, this is what the simulation for gas leakage detection. We can use the same in the real world. Okay, if you are working in a company, okay, if you have some gas leakage, you can have this device setup. Okay, Arduino board, then all these devices. Okay, then we can use this coding and we can run this simulation. Then another one simulation activity in our Tinkercad is safe distance alert system using ultrasonic sensor. Say, think that you are being you are riding a car, okay, driving a car, and you want to make sure that you are maintaining a safe distance with another car or another object. Okay, so for that we need some safe distance alerts system using ultrasonic. Okay, so nowadays all the cars are having that all the modern cars are having this sensors like ultrasonic sensor or distance sensor, or they have some sensor like collision sensor, whether the car collided with some other car or not. Okay, all the things they are being read by sensors. Okay, so here I am using ultrasonic sensor. Okay, so in movies you have seen, recently I have seen a movie like Animal. Okay, in that movie, right, that that person, no, that the flight wasn't, no, that it was not it was in the flight mode, right? So that the hero and heroine by being they are inside, no, they're not which one, they're not controlling the flight. Okay, so when the flight is about to the which one, the plane is going to hit an object, that time only the alert sound came, right? That time only that person will go and control that flight. Okay, so it's like it is automatic pilot mode, autopilot mode. Okay, so that time whenever the object is going to hit anything, no, any other object or any other object is nearby your area in your range, that time only the alarm will be raised. That time you can take the control. Okay, that's what safe distance alert system using ultrasonic sensor. Okay, so for that what I did is I have another simulation tool here. So same in Tinkercad. Okay, we'll go to Tinkercad, another simulation activity. So here I know I'm rushing because I have only 1 hour time, right? So I'm rushing. Okay, so here we have a safe distance alert system, another simulation project. Okay, I will tinker this, then I will show you what are the sensors we are using here, what is the controller, what are the actuators. Okay, so here again Arduino controller, and controller, that device used for running, okay, program, okay, connecting all the sensors to Arduino. And we have breadboard. In the breadboard I connected which one, ultrasonic sensor or distance sensor, and this is the buzzer, and this is RGB LED. This LED can produce, the earlier activity we had two LED, right, red and green separate LED, but in this activity I have single LED which is called as RGB LED. That LED can produce red, green, blue, all three colors. Okay, so this is the distance sensor which will read the distance between the object. Okay, and this is the buzzer. Okay, now I'll show you the code. So in that code, as I told you, wherever you connected the devices, the pin numbers are showing, right? Red 7, red LED, that RGB LED has 3 pin, I told, no, 4 pin, right? So red will be in 7th pin, then motion sensor 3rd pin, right? Green LED 9th pin, buzzer will be 10th pin. Now in the setup function, I have to initialize the input and output device. Okay, so we have all the red, green, buzzer, all LEDs and buzzer are output device. Okay, then I have the code for reading the input. Okay, so I am reading the input. After I read the input, what happens? See, I am checking the inches less than 25 and centimeter less than 70, the distance. Okay, I'm reading. If this is the condition, red LED high, and the buzzer will be producing a sound, and green will be low. Okay, so this is a condition I'm checking. The distance between my car and another car, or my car to another object, is between this range, means LED will be, red will be high, buzzer will produce a sound. So by the time now the driver gets alert. Okay, if he is in a letting relax, means he can when you get the alert, means you will be when you get that alarm and the message, he will be alerted. Okay, else otherwise green high, no buzzer. Okay, green will be high, no buzzer, red will be low. Okay, so here we read the input and we check the condition. Okay, so now how do we run this? Okay, let's show this start simulation again. When I initialize, no, see here, now the distance is we have in a safe distance. Okay, that's why it is a green color. Okay, now the buzzer is not producing sound. So how do I make that distance, reduce the distance? Okay, I press this alt key in my keyboard, then press this ultrasonic sensor, then I want to reduce the distance. Okay, so what I will do, first I will drag this device. Okay, this one. Now I will press my, see, the inches is 43, centimeter is 1095. That means the object is in a far away. Okay, distance is safe distance. Okay, but I want to test now. So what I will do, I'll press the alt key of the keyboard. Then I will see move the mouse cursor. When it is, see, less than that 25, whatever condition I put, no, the inches and the centimeter, whatever I put in the condition, right? What was the condition did I put? 25 inches and 70 centimeter. Less than that value means what happened? Again, see, now it is safe distance, no alarm, and it is green color. When I reduce the distance, see, whenever it is less than 25, see, it is red color and the bus will be on. Okay, this is what safe distance alert project. It now it's being used in all the vehicles. Okay, whenever you want to have some alert about your which one the car be hitting, going to hit another car, or distance maintaining, all those things we can use this. Okay, no, you know that in real future we'll have that which one driverless cars, no, on that in that cases, no, I think in some countries already we have driverless car, right? So in that cases, no, we'll have sensors. Every sensor will be attached to the car. So that case, we need the distance sensor, we need the alarm, we need the collision sensor. Everything should be there. Okay, that's the use of this which one distance sensor or ultrasonic sensor. Okay, so that is done. Then what I have is detect motion movement using PIR motion sensor in a room to turn on fan, light, and buzzer. Okay, so again, I want to make sure somebody is inside the room. Okay, see, so when you are entering a hotel or when you are entering a which one, what we call it, yes, hotel. Okay, when you're entering a hotel, that time you don't want to go and turn on the light or fan or okay something. So what do you know? There's a sensor over there. Whenever you enter the hotel, the motion sensor, the PIR motion sensor, right, passive infrared, okay, so that sensor will detect the motion or movement, and whenever you are inside, no, that motion sensor will read it, and based on the value of the motion sensor, the program I have written the controller is they will turn on the fan, light, and buzzer. Okay, that's the third one. The same thing we did in the packet tracer, but in Tinkercad it's it's a different way. Okay, I'll show you that also. Go here, go to Tinkercad, another activity. Here, safe distance gas leak. Now this is let me check here. I have so many activities here. Okay, see here, motion detection to turn on the fan, light, and buzzer. Okay, so I'll tinker this. Tinker means I'll go and run it. Okay, so this is again Arduino. We are using all the Arduino boards in this Tinkercad. Okay, so Tinkercad Arduino board, and this is for simulating the fan. We have a motor here. Okay, then we have a motion. This one motion sensor. Okay, PAR motion sensor. This is the buzzer. Then we have LED and we have resistance. Okay, all these are connected to Arduino. We have different pin numbers. Okay, so this one motor has 3 pin. This is the power pin. We connect to the breadboard power. Then this is the grounded pin. This is a signal pin connected to digital D5. This is motion sensor. Again, 3 pins. 2 are power and ground. One is power and ground. Another one is the signal pin connected to digital pin 2 D2. This is buzzer. The negative grounded, the positive, the signal pin connected to D4. Okay. Then for powering the breadboard, no, we need to give plus and 5-volt and ground to the breadboard. Now I'll show you the code. Okay. Same thing. First, you have to mention the pin numbers. Then we have to go for mention the input and output device. Okay. And here I'm going to read the value of the motion sensor. Okay. PIR motion sensor I'm reading. Okay. Then if the value is high, and if the motion detected, and if the value is high means buzzer will be on, LED will be high. Okay. Then servo 1 dot right of 90 means now this is the servo motor. Okay. Servo motor, the object. Okay, the this is the class, this is the object. Okay, so in that object I have to write a function, call a function, right? And what I'm writing is 90 any. I am asking the making the motor to rotate 90 degree. Else if nobody is moving means we don't want to turn on the fan, right? We don't want to turn on the motor. LED will be low, no buzzer. Okay, so the same thing I am going to start simulation. I already discussed the code. Okay, start simulation. When I start simulation, what happens? I have to go near this, right? The motion sensor, and I want to move that which one? When you have to move in there, the motion sensor, no, that we have to turn on this motion sensor. See, it's the range. Okay, so whenever it's the range. Okay, now this one. See, 90-degree rotation, again it will go back to the previous stage. Okay, this is again that same we did in the packet tracer, but it's in different way in the Tinkercad. Okay, so whenever the motion detected, then this motor, this servo motor will rotate. It's like a fan. Then the buzzer will be on. It will be on. Okay, this is again what another simulation of activity in Tinkercad. Okay, Like that, we have many are there. One more is there, detecting the door open or not using flex sensor. Okay, say assume that one person is say unfortunately blind. Okay, so if his door is closed, okay, so door close means actually what we need is whenever someone enter the door, the alarm should be there. Okay, or actually we need to put an alarm, okay, like buzzer, so that whenever someone enter the room, by hearing that alarm buzzer sound, the person who is inside the room should be alerted. Okay, so here what I have is a flex sensor. Flex sensor means this is a sensor, flexible sensor. Okay, I mean flex means flexible sensor. This sensor is attached to the door on the floor. Okay, the ground, no, we put this sensor, okay, on the floor. So whenever someone is opening the door, this flex sensor will bend. This is flexible, right? When this is bending, based on the uh, value of bending, how much it is bending, we will write the code. So the bending is more than some, okay, more than a particular value means what happen, no, the alarm will be raised. This is the which one purpose of this simulation activity. For that, again, I'll go back to Tinkercad. Okay, so I have a activity for this movement detection using flex sensor. This one, actually, here what I did is I have put the flex sensor and actually one fan. Actually, I should have put a red LED, but I just put a fan here. Okay, so here I have the show you that which one topology. Okay, so in that topology, I told you again, as I told you again, I'm telling like this is the Arduino board controller. This is the breadboard. Here I have the flex sensor. I'm connecting the 2 pins of flex sensor. Okay. Then we have the servo motor. You can even connect the LED also. Just drag and drop the LED. You can also connect here. Okay. So that you can connect like this. Okay. If you want to rotate, you can do like this. Okay, can connect the cable, we'll do later. Okay, so this one, and connect the servo motor 3 pins. 2 pins are for ground and positive, one for signal pin, digital 3, and this is the input device, yani flex sensor. Okay, this is connected to A0. So what I do is, okay, this is the declaration. Okay, so here see, I am reading the analog read of A0 means I am reading the value of which one flex sensor stored in the flex value. Okay, then I am mapping the position. The flex sensor value will be, I'm putting maximum and minimum as 0, minimum, maximum 180. Okay, and the position based on the value of the servo motor, value of the flex sensor, no, I will rotate the servo motor, right? So instead of 0 190, I will take the value from this servo, this one, this flex sensor. Okay, this flex, when how much it is bending, based on the bending, you will get 0 to 180 value. That will be stored in servo position. That value we will give into motor. The motor will rotate based on this value. Okay, now let's see the simulation. See here, start simulation. Now this is 0-degree bending, so it is not rotating. Okay, so what I will do, someone is entering the room. So when someone enters the room, what I will do, we have to manually, because it is no door connected, right? So we have to manually bend the flex sensor. When I bend the sensor, based on the bending, no, see the motor is rotating. Okay, when I take it back, motor will come back to the previous stage. Okay, if I have a LED there, based on the bending, the LED will also glow, and we can put the buzzer also. There is a buzzer, just I will show you there is a buzzer. Buzzer, we can put the buzzer here. Okay, actually I didn't put the buzzer here, just I'm telling you. Okay, these are the simulation activities I have added in my, there are so many there, we don't have time for discussing all those things. Okay, now we'll go for the details about the language. Okay, so for all these things we need to write some language, right, some coding, right? For that we have to discuss about Python. So I'll invite Dr. Bragram to tell you some details about the Python language.
Thank you, Rajesh. As all of you know, Mr. Rajesh was a little bit hurry while while giving all these details to you, while explaining the simulation part. Because according to the instructions from the organizers, we got only 1 hour 40 minutes time to complete all these topics for the session time. So it's not at all sufficient. You know, it's unfortunately the time is not at all sufficient to complete all the topics deeply. So we are we are anticipating that you will get a basic idea, basic information about this Python programming part and the IoT, Internet of Things simulation. We'll go with the standard programming part of IoT, that is nothing but Python. Python programming we are adopting now. We can use any of the programming languages in adapt with the Internet of Things, but Python is mostly adaptable and it's a leading programming language nowadays. You know it very well. It's developed in 1991. Mr. Guido van Rossum, he's a Dutch nationalist. And after 1991, for around 20 years, it was in very much in ideal stage. But after 2015, again, the Python programming language emerged as one of the leading programming platform, as it replaces many of the existing programming languages because of two reasons only. It adapts highly with any of the existing technologies, and the second one, a rich set of libraries and packages. We can tell like that one. As you know, many advantages are there for Python programming language. Is ease of use, a large community is there, and rich libraries. This is one of the most important point regarding Python, because almost all the vast collection of libraries are supporting with Python. It spread its wings to data processing, visualization, machine learning, network communication, in many of the things. And cross-platform compatibility. I told you this adaptability is a highly flexible with Python programming language. Compared to any other programming language, as we know, we have many programming languages we are using in different types of technologies. For mobile development, we can use Delphi, we can go for C#, we can go for Qt. Many development platforms are there. But why Python? Because of rich libraries and a cross-platform compatibility. This is it's 100%, we can trust it. So after this, we are going for some introduction. I'm not going to type any programming language part of this one, because you know it very easy one. The syntax are very easy one, and the execution blocks are very easily identified, and it's easily modified with existing indentation part. So this Python, some basics they have given, as you know, programming code, because almost all the universities, almost all the organizations, they have adapt this programming language as part of their curriculum, as part of their development platform, because it's highly useful and adaptable with any of the technologies. So they have given some of the things here. While developing Python, you can directly go with the Python installation. As you know, python.org is the website for that one. You can directly download the Python for any of the platforms. Which operating system you're using, any of the operating system, for almost all the operating systems, the Python is available. And you can directly download it without any subscription, and you can install it. And from Google, if you're searching, you will get some IDE. Of course, it doesn't support, the Python doesn't support any of the good IDE, integrated development platform, just like any other programming languages. But because of its adaptability and because of its rich libraries and a rich set of packages, now this is the leading one. But you can go for many of the IDEs. Some existing IDEs are there. You can go for some Python and some PyDev. Eric is there. KDevelop. NetBeans also supporting, because it's a Java specific software, freeware. But still, Python you can develop with that one. And many IDEs are existing in Python. And one of the most important IDE, you can directly go for that one, Anaconda platform. Anaconda platform, Jupyter platform, Jupyter pad, you can directly use to code it, or you can directly go for any other IDE, because for each IDE they have their own specifications are there. And for installing packages, many of the packages are already installed in Python, but you can directly download many of the packages from internet, and you can install it. The installation process, you can go for packaging.python.org website. You can directly go there. The installation method they have given here, they're mainly focusing on Unix and Windows. The Mac OS installation is almost the same like Windows. You can directly double click and install it. And many of the packaging, almost all the organizational needs packages are available in pypi.org platform. It's the website. You can directly go there. You can find it. You can download it. The installation method also they can give here. So whenever you're going for Unix or Linux command or console, you can directly go for the version checking first. Immediately after the version checking, you can directly put a direct pip command, and you can directly install the packages. Whichever the packages you need, you can directly download it. For Windows installation, you can directly download the entire zip file. You can unzip it and you can install it. So pypi.org is one of the important website. This is mainly for downloading your necessary Python packages, and the installation instructions are also there. GitHub repositories are available. You can directly download your codes. Even the GitHub is also highly supporting Python programming, because many of the developers, they have directly installed all these programming languages. You can directly download it, and according to your use, you can change it. So some of the GitHub repository, I'm not trying to list it out, but it's there. Python project-based learning and Python programming exercises, 100 days of ML coding. For these things are highly useful for your machine learning purposes. And they have given the application areas also. As you know, Python can be applied in almost all the application areas, because all the standard packages are already installed. Even Google platform is also Google Collaborators. You can directly go to Collaborators. The platform already had many of the existing packages are there. You can directly download it. You can change it according to your use. So Google Collaborators are also supporting the application areas of Python. You can go for data science and big data, machine learning, artificial intelligence, metaverse, blockchain, robotics, and TSR. Previously we were using C programming language only for TSR programming, that is terminate and stare resident programs, because it's highly dangerous programming. Normally we will call like that. It's a very highly dangerous and critical programming. So these TSR programs after C programming language, now Python is also supporting that one. So you can directly go for robotics and TSR programming with this one. OS hardening. So give the high security for the OS kernel hardening. You can go for Python. Even Python is useful for your gaming, your security measurement purposes, medical and diagnostic purposes also. Almost all the areas Python is covering. So that's why Python is very leading nowadays. And these are packages we have used as part of the implementation and the simulation done by Mr. Rajesh. We have used all these important packages. These packages, you can note it down. These packages, you can directly use it for your projects also. Whenever you are going for any simulation purposes, any simulation projects related to Internet of Things, these packages are some of the standard packages. You can directly use it in your project. You can start with these projects. These importing packages are available in your this one, pypi.org. Directly you can visit this website and you can directly download it, you can install it. There is no need for any other compatibility issues will not be there. And they have given here import HTTP lib2, the comprehensive HTTP client library. If you want to go for any communication platform, you can directly use HTTP client library, and it is coming under import HTTP lib2 library. And we have used URL lib3, and it's a powerful, user-friendly HTTP client, and URL lib plus import URL encode. For example, if you are using any uniform resource locator, URL strings for your communication purposes, you can break it into number of strings. According to the strings, you can send your packets, and the communication will be established. So this from URL lib parse import URL encode, you can use for breaking the uniform resource locator URL string. So you will get number of strings. Each and every string you can use for your communication purposes, for capturing the packets also. And for internet resources fetching, we have URL lib. Directly you can request it by using this library. And a communication platform client, for example, if you want to send any particular message to your mobile, and for example, if you want to communicate with the cloud system, you can directly use import client package mechanism. And of course, as part of the IoT, Internet of Things projects, import a GroupI. Directly they have installed all the board communications, all the board sensoring libraries they have directly installed. So GroupI Plus, it's an open source platform actually connecting Group sensors to the Raspberry Pi. Okay, all these packages are open source packages. You can change according to your need after downloading. According to your communication need, you can change these existing libraries also. That is also possible in Python. And of course, we have OS modules. For example, if you want to communicate with the underlying operating system modules, if you want to communicate with the kernel hardening or kernel security measurements, you can directly import OS module. And time module, of course, the conversion operations of the times are available in import time. And group RGB LCD import means whenever you are using any particular display in your Internet of Things with the group I board, you can directly use group RGB LCD import. And for the sleeping time, for example, the delay for evaluation. Whenever you are doing some evaluation for your measurements, if you want some delay in between, you can go for from time import sleep. Then check the system behavior according to the pin change. For example, you are changing the pin from one port to another port. The board communication cannot identify it automatically, but the Python programming code from GPIO import star, all the modules are available in GPIO. It can automatically identify the pin change. And of course, all the time related modules and configurations are available in time.import package. Okay. So only these things we want to communicate with you as the part of Python. It's a basic Python module actually. The programming is very easy. As I told you, only the intonation part is a little bit difficult for the Python coding. The rest, everything is fast, and rest everything is adaptable with Python programming. So thank you for this one. I think Mr. Rajesh will continue. The rest of the part, we are going to finish it.
Thank you, Doctor. So we'll have an packet tracer activity again for describing this Python coding. So IoT based automation of high-ended parts system using Python program. So we'll go with this one, packet tracer. So we already discussed two packet tracer activity, but there was no Python coding. It was simple coding, okay? If and conditions were put in simple if, no. So here we have the actual Python coding. So we did a small activity for which one? Packet tracer implementation. So instead of having that home gateway wireless router or having that IoT server, no, we have used the microcontroller, okay, MCU, okay. So this one we use from here, the MCU board, okay, the single microcontrol unit, okay, and we can also use a single board computer, both we can use, okay, but I'm using MCU here, okay. So here, as we discussed earlier, no, all the sensors and actuators, all the input device, output device should be connected to the controller. This is the controller. So there are so many digital and analog pins, okay. I'm connecting all these devices to these pins, okay. So here I have a LCD display. Then this is a camera. This is an LED just to simulate the light. Then this is a sprinkler. Now, when you are getting into garden, we need a sprinkler, right? So that one sprinkler. Then this is AC, then this is temperature sensor. This is a heater. This is motion sensor. Then this is the which one? Entry. Okay. When someone entering into the park, we need to have a entrance like this. Okay. So this is the which one? A coffee vending machine. This is like a wind detector. Okay. So all these things I use for simulating a which one? Park, automated park. Okay. There is no security guard there. When you are entering this gate, no, this should be open. Okay. So there is no manual controlling here. Okay. Everything is automated. That's why automated park using IoT. Okay. So here we have to first which one discuss about the coding. As Doctor was telling about the Python coding. Okay, so I'll go to the which one device SBC single board computer. We can either use SBC or MCU. I think I'm use SBC here, MCU another one. Okay, so in SBC we have programming. So in the program I have written Python program. Okay, main.py. It's actually running. I'll stop this. Okay. Now see in this program I have two packages, okay, GPIO and time. So GPIO, as he was discussing, general purpose input output. So from here I'm importing star. So I'm importing all the general purpose input output statements from GPIO package. Okay. So what are the input output statements is, right, custom write, okay, read, digital read, right, all those input output statements are coming under which one? GPIO. Okay. Then from time, another package is time. I'm importing star. So here I have a delay and sleep function. Okay. So if you want to put some delay, I can call sleep or delay function here. Okay. So this is the use of those which one packages. Okay. GPIO means general purpose input output. Another one is time. Then inside the main function, I have first thing is declaring the pin numbers. Okay. So what are the pin? What are the mode? So here I have 1, 2, 3, 4, 5, 8, 9 devices. Okay. So 9 devices, each one has a name. So The device which I connected in 0th pin is motion sensor. So, I am reading, I am detecting the motion. So it is an input device. And camera is an output device. So I put pin number 1, mode output. Garage door is an output device. So pin number 2, I connected garage door, output is the mode. Like that, sprinkler is an output device which will spring water, like spray water in the garden. So again, it is connected in 3rd pin, mode is output. LED simulating the bulb or light or tube light, right? So that one also output device. It's in pin number 4, the mode is output. LCD display, it will display the message, welcome message when you come, when you get inside the park, they will show you the welcome message. Okay, when you are leaving the park, it will show bye bye. Okay, that message also displayed in the LCD screen. That also an output device. The pin is 5, mode is output. Like that, coffee vending machine. See, whenever someone is there, so when after enjoying for a long time, we need to have a tea or coffee, means you can go for the machine. Okay, that is also automated. That will be on, and the mode is output, and the pin is 6. AC. Okay, so there is a room for the elderly people to go and relax. No, there I have put the AC and heater. So for that we have AC room. Okay, so that AC also output device, the pin is 7 I connected. Okay, and heater also there. So if you are in Norway, so Saju was telling like it is very cold place, so there is no need of AC, we need only heater. Okay, so that time you know to turn on the heater, right? So heater will be in connected to pin number 8, the mode is output. Temperature sensor, I want to read the temperature. Okay, automatically based on the temperature I read, I will turn on the AC and heater automatic. There is nobody to go there and turn on the AC heater. Based on the readings of temperature sensor, by using that coding, okay, if it is going below some range, like the temperature is, example, I put 500, okay, the temperature is above 500 means AC will be on, or heater will be low, like that. Okay, so again, it is input device, I put in pin number 9. So why I connected all this, why I put these pin numbers, because in the topology I have connected like this. In this controller, SBC or MC, whatever controller, I connected all these devices in this particular pin. Okay, see here, this camera is in digital pin D1. Okay, that LCD I connected in pin number 5. Like that, all the pin number wherever you connected, you should mention that pin number in this pin mode, 0 input, 0 output. Okay, now by default we have a print blinking message. Okay, then just put a message print blink. Then inside while true, continuous loop. Okay, so while true, I am going to read the value of the motion sensor. Okay, so this is my motion sensor. Where's the motion sensor? Here. Whenever the motion is detected, the value I will be storing into MOT. Okay, then I will print the value of MOT. See, here already I have printed the values here. It is 0. Nobody is moving means it is 0. Okay, when someone is moving, the value will be more. Okay, increased. Okay, now see here, when someone is moving, again I think I forget to close that one. Okay, again sprinkler. See, when anybody is moving, when someone is moving means the value will be 1023. Motion sensor value will be 1023. Okay, and how we know the motion sensor value is 1023 or not? Okay, for that what we need, open the motion sensor. When you click the motion sensor, there will be specification. Okay, see, when you click each and every device in packet tracer, every device will have specification. So see here, if you don't know about the device, you can read the specification. That sensor detects the motion. Okay, so what is the value, everything will be here. Okay, every device will have the values. Okay, I'll show you one by one. See here, if it is AC, when I go for AC, go to specification. See, this is AC on means the value is 1. 0 means AC is off. Okay, and like this every device will be having, and the function, see, digital write. If you want to turn on the AC, digital write, and you have to put value 1. If you want to turn off, make it digital write 0. Like this, say if you go for LED, if I take LED also, go to specification, you can see the value maximum is 1023, minimum is 0. Like that, we have input and output device, output functions for input value, output value functions, everything for each and every device. Okay, based on that only we write the code here. Now the motion sensor, if anybody is moving, if anybody moving here, the value of motion sensor will be 1023. Okay, so I will see this when you run the program. Okay, when if the motion detected, yani that means if the mode, the variable equal to 1023, and if statement here, as doctor was telling, there's some syntax in Python, right? So if statement, usually when you are writing C and C++, we have curly bracket, right? But here we have this colon. So when you put the colon, yani a colon means then all the statements coming inside if will come under this indentation. Okay, now first one, custom write 1 comma high, that means whenever the motion detected, 1 means camera will be turned on. Then what about custom write 2? Custom write means the function used to enable turn on a output device. Okay, read means we are going to get the data from input device. Write means turning on the output device. Okay, so 2 comma high means what is 2? Garage door. So when someone is entering, no, the garage door will be open. Now 3 comma high, 3 means sprinkler, it will start sprinkling, spraying water. 4 comma 1023 means I am using LED. Okay, 4 is LED. Then why you are using analog, right? Because digital, digital has only two values, 0 or 1, high or low, but analog means we have continuous values from 0, 1, 2, 3, maximum 1023. That's why when I turn on the LED, see here, when I click the LED, I can see the specification. Maximum value of LED is 1023. Okay, that's why to turn on the LED, I need to mention the pin number 4, value 1023, and use the analog write function, because I am writing analog value. See here, analog write, already it's mentioned here, analog write is the function you should use. Okay, every device has mentioned the function, the value, everything in the specification. Then make the sixth pin 1. What is sixth pin? Sixth pin is coffee vending machine on. If anybody enter the park, right, you want to turn on the coffee vending unit, right? Then 5 comma welcome to park, that means that 5 means the device is LCD display, they will show the message welcome to park. Okay, and give some delay. Okay, after that, if motion is not sensed, nobody is coming, means everything should be low, and the custom right, the LCD will show buy message. Okay, then another one condition is temperature. So I am reading the temperature, and the condition for, or the statement for reading temperature is analog read of 9. So why you are using 9th pin? Because I connected the temperature sensor in 9th pin and its input device, and the temperature sensor I am using analog read because it reads temperature. We are reading continuous value. I am not going to read the temperature like 0 or 1. I am having temperature so much values, right? We'll get continuous values. See, where is the temperature sensor? This one. Okay, when I click the temperature sensor, when you go to specification, you could see the values. Okay, see here, the values will be, it's not 1 or 2 or like 1 or 0. Okay, it will be started from 0 to 55, or it will be showing more values. Okay, so I can use the value only analog read. I will use the function analog read because the value which I am mapping, which I am reading is not 0 or 1 like motion sensor or some other thing. I am reading values will be like 0 to range some 255, 500, some values will be coming in this range. So we need to read the continuous values. We need analog read function. Analog and digital has only two value, 0 or 1, high or low, but analog means continuous values. Okay, now just I put a condition for testing. Okay, if temperature greater than 500, because the normally temperature it sensor takes some time for reading, that's why I put temperature greater than 500 means 7 high, 8 low. What is 7? 7 is AC. Okay, then 8 is heater. So temperature is more means I want to turn on the AC to get cool. Okay, otherwise you have to turn off the AC, turn on the heater, 8th pin. Okay, this is the code. Okay, so if once you go through the Python syllabus, Python syntax, okay, if statement ended by the colon, once you finish all the statements inside the if, what happened? You have to write the else. Okay, else also you have so many conditions, means you have to put the colon. Then once you press the which one cursor, it will show the location. See the cursor location where you want to type. You cannot type here. If you type here, it will show error because the statements are inside the if. That means the cursor should be wherever the cursor showing, no, that location. We have to type the statements inside the particular cursor location. Okay, now I am going to run this program. For that, we need to go for a run button. Okay, when I run this, we can see now no motion. Okay, the door is closed. What I will do, I'll go and press the alt key and I will move. Okay, move the cursor along here. What happened? The door is open, the entry is allowed. Okay, now the camera is on, welcome to park, coffee vending machine on, camera. Now I release the which one, mouse cursor. Now see, by camera is off, light is off, sprinkler is off, AC is off. Again I will turn on the which one, move the cursor, motion detector. Now see, sprinkler on, AC is on, everything is on. Okay, now I'll go for the temperature sensor. Now after a few seconds, I release my which one, finger over the alt key, then the motion sensor is not working, everything is closed. Okay, now I'll go for the temperature sensor. Now check what's the temperature here. Now the heater is on, right? What is the temperature? Now the temperature is 381. Okay, any less than 500. Less than 500 means the heater is on. That's why heater is on. Now the temperature is greater than 500 means AC will be on. Okay, so that case, in some cases, now it takes some time. It reads from the environment, right? Environment, right? So it will take some time for the temperature to go above 500. That time only AC will be on. Okay, here now see, the motion sensor is not detected. Motion not detected. That means the values printing is 0. That means no motion. Now see, slowly the temperature is going up. If it is reaching 500, AC will be on. Till that time, the temperature will be, it will be displaying, it will be turning on the heater only. Okay, this is a simulation of how we run the Python program in the MCU. Okay, the same program we write in the Raspberry Pi. Okay, in the real world, right, we will write the program in Raspberry Pi. Okay, now I have, I think, few more minutes left. Okay, so I'll go through a real coding. Okay, real project coding. Okay, in our college we have bachelor project. Okay, in that bachelor project we have, okay, so in that bachelor project I'll show you the coding. Okay, so this is the, let me, this is the I think it's last semester bachelor project. Okay, so this is actually used for the bachelor project. There we have the same header files we have. Okay, then we have some sensors: ultrasonic sensor, water sensor, motion sensor. This one is actually used in the ship. Okay, when a ship is going to, automated ship, okay, when a ship is going to hit another ship, okay, another object, means we have ultrasonic sensor. Okay, the ultrasonic sensor, the distance read is less than 10, say example. Okay, less than 10 means, or 10 kilometers means, what happened now, objects are closer, so make the RGB LED red color. Okay, then the message will be displayed on the screen, objects near ship. Then we have buzzer on. Okay, now what is this Tivilio? Tivilio means, see, whenever your ship or something is going to hit somewhere, now we want to send alert message to police, right? So for sending the message, alert message to police, we have used Tivilio application. Okay, Tivilio application means is a which one application used for sending SMS. Okay, so I can have a, I will get a mobile number from the Tivilio application. Okay, it's a real world. Okay, and I will type the mobile number of policeman. Okay, so by using this code, this is the username password for the Tivilio application. By using this code, what happens, they will send a message. What the message they will send is, objects are, see, objects are nearby the ship. This message they will send to the mobile phone of the policeman. This is the application called as Tivilio. Okay, then another one, like see, water, say there is a leak in the boat. My boat is having which one leak. Okay, that time we have a water sensor. The water sensor is 0. What happens, there is a message going into the which one, the alert system. Okay, there's a SMS message going into the person, maybe policeman or someone in the which one, someone, right, that the person who is attending all these messages, they will get a message like there is a leak in the boat. Okay, then we have motion sensor. Say some, the boat is not moving. Okay, the boat hit another thing, another object, or some boat or some mountain or something. Okay, so if anything is detected, if anything happens now, that message also sent to the motion detected, also sent to the, or no motion detected, also sent to the mobile phone of the concerned person. There I'm using motion sensor. So motion sensor, I'm reading the motion sensor value. If the motion equal to 1 means motion detector, no motion means this one. Now someone asking, can you upload the value to cloud? Yes, we have uploaded the value. All these sensor values are uploaded the cloud, okay, platform. So the cloud we are using is ThinkSpeak. Okay, we have to create an account in ThinkSpeak. So I'll show you my ThinkSpeak account. So thinkspeak.com, I have a cloud account there. So let me show the ThinkSpeak cloud. Okay, I have to check that login. Let me check my login. So let me log in. Actually, I logged in, but now I logged out. That's why it is taking time. Okay. So the projects I have, I think we can put only 5 to 6 projects for the trial account. Okay, so it's a free account. Okay, I didn't create which one, I didn't pay for this. Okay, so these are the projects I put. Okay, so 4 projects. So we'll go with the first project. I think this one is first. Okay, see here, when you open the thing, which one, ThinkSpeak cloud, this is ThinkSpeak cloud. Okay, so here we can upload the values of the sensors which you read from the Raspberry Pi, right? That IoT sensors you have now, that values you can upload in the cloud whenever you're running the program. Okay, so whatever sensors we have, all the sensor values we can upload in the cloud. This is, see, taken at July 23, This is last year, right? January 22, July 23, like that. All the sensor values, smoke sensor, then ultrasonic sensor, this red color. If it is an alert, no, distance less than 10 means red color will come. Otherwise, green color will come. So like all the sensor values I can show in the cloud. Okay. So what I have to do is I have to just add the code like this. Okay. URL is the link of the cloud. Then there is a key for you. When you register, you get a key. Then header, how many fields you are creating in the cloud. Whatever field you create, you have to mention the fields. Okay. See here, I'm using this one U means ultrasonic, then water means W, what this water sensor. All these values you have to put in this one. Okay. Then you want to make the new URL. Now what happened? Whatever sensor values you have in the real device, all things will be uploaded into your cloud platform by using this line. You are open the URL. Okay. URL open function inside URL lib header, which one package in the request. Then we can go for this function. Then you can upload this new URL and all the values in the real sensor will be uploaded to the cloud. Okay. This is a real project. So there are like that many projects we are doing. Okay. So that's what we have to discuss about this in this workshop. Okay. There is a Cisco learning platform. There are so many courses Cisco is offering. Internet of Things, fundamentals, connecting this, so many courses. All these references also there. Okay. You can go through that. And we have a YouTube channel also. Here I'm uploading all these videos and all. If you want to get some idea about the video, whatever, how I did all these activities, you can visit this channel. Okay. That's all from our side. Thanks to Saju for providing this opportunity for us. Okay. Saju, back to you.
Subi, are you there?
Yeah. Yes. So now the session is open for the queries, and you can shoot out all your queries here. And now speakers will be answering all your queries.
You have any questions you can ask?
Excuse me, sir, I have a question.
Yes.
Yes, why Python is nowadays mainly used in technological development?
Actually, I told this, while explaining, I told this one. Mainly, Python is used because of two important things: the adaptability and the rich set of libraries and packages. Almost all the field libraries and packages are available in Python. So we can easily use it. We can easily adapt with any of the existing technologies, any of the existing field. So that's why we are, we are adapting this Java. Instead of Java, we are going for this Python. Actually, for every development, for each and every development, we have separate platforms we are using. Still, we are using separate platforms out there. For example, 15 years before, we have used Java for many of the software-oriented projects we have used. For mobile-based applications, we have used Delphi. We have C#. We have used for Linux-based applications. We went for Qt development platform. We went, but after nowadays, I mean, for the past 5 years, we are highly adapting with the Python programming language because most of the packages they have already implemented there. So we can directly drag and drop use it. That's the main thing.
Any questions from here? You can ask.
Excuse me, doctor.
Yeah, excuse me.
Yes.
Yeah.
Yes. Tell me.
Hello.
I have a question. Yeah, I have a question.
Yeah, sure. Just a sec. Let me take it for a moment. Yeah, thank you. This is to tell you about feedback forms. All the feedback forms will be sending you to have your valuable suggestions to us, and you are kindly request to please share your valuable suggestions. And soon after, when you will be filling your feedback forms and you will be uploading to us, your participant certificates will be distributed to you. Yeah, so now we can move on back to the questionnaire session. Yeah, Miss Asma, yeah, you can continue.
Yeah, okay, thank you. How do you protect IoT devices from security attacks?
Asma, it's a good question. Like every device connected to internet, we also need to protect these IoT device also. Okay, all the sensor data will be personal informations. Okay, so all this data protected First thing is we have to protect the Wi-Fi network. We are connecting all these devices. Okay, we should have a separate guest network for connecting all these IoT devices. Okay, and these IoT devices, sensors, all should be password protected, and they should not use the default username password, and they need to use multi-factor authentication, like not just username password. They should go with some OTP, SMS messages, or the email alerts. No, all those things should be used. Okay, like that, there are so many security techniques you have to follow for making the device protected from security attacks. Okay.
Okay, thank you.
No questions?
Me also, I have a question. Mr. How do you upload the IoT sensor data to cloud platform?
Okay, Mrs. Ma. So as we discussed in the last part of the session, hope you can see the screen. No. Hope you can see the screen. My screen. Can you? Is it visible? No, my screen is visible. No, okay, leave it. So
Yes, sir.
there is a cloud platform called as ThinkSpeak. Okay, so there is a cloud platform, thingspeak.com. So in this cloud, we have to create an account. Okay, once you create an account, now there is a channel. You have to create your own channel. See, if I am going to upload my values of my student project sensors, no, you have to create a channel. Say I have 4 channels. Okay, so in the ThinkSpeak cloud, we have to create a channel, and in that channel, we have to create how many variables. Okay, how many fields you want to create. Okay, and we have some keys here. So for every channel, we have some key. See here, write API key and read API key. Okay, these keys you have to add, copy paste into your program. See, you have copy paste the key in this field, key equal to this one. Okay, for every project, they will give some key. That key you have to copy paste in your project, and the URL means the link of the ThinkSpeak cloud. Okay, after that, header field, how many fields you create in the ThinkSpeak cloud. Okay, so here I have my channel settings. So I'll go for my channel settings. Okay, in the channel settings, I have to mention the name of the project, the description, then how many fields you want. See, if I want only 2 fields, okay, I have to click only 2 fields, and I have to give the name of the sensors. Okay, after that, what I will do, I want to write this header equal to field 1, field 2. How many fields you created in the ThinkSpeak? Same number of fields you have to create here, and write the function format, then name of that field, no, whatever sensors you have, put it here, then write this URL header. Then by using this function, whatever you enter, whatever sensor value you enter in the, you get read from the, right, whatever sensor value you read from the program, no, all these value will be uploaded into your cloud platform, and you can see live. Okay, immediately you can see the values. For that, we have to make your channel public. Whenever you make a channel public, then you can see the values of your sensors in the cloud platform itself. So this is the method of uploading the value of sensors into cloud. This is thingspeak.com is a cloud we are using. We can have Azure, Microsoft Azure, but still we are using ThinkSpeak because the coding is easy for us. In Python, the Azure, there is a ThinkSpeak, and Python is integrated. So this link, so you can easily upload the value into ThinkSpeak. Okay. Hope Asma, you understood the answer, right? You got my point, right? I think she left. She understood.
Rajesh?
Okay. Yes, sir. Yes, sir.
I have a question actually. So for see, in your simulation tool, we used the Python programming. So
Yes.
should we need to write the code from the scratch, or your tools support some kind of template to start with?
No, simulation, packet tracer and all, we have templates are there. Just I will show you this go. I will take one activity. Just you don't want to write the full coding. They will give the template. There you want to fill in. But basic things are there provided. But if statement and all, we have to enter. Okay. Just I will show you that packet tracer.
Okay. So the
Just I will
logic
show
we have to build, so the template will be
that
there.
you have to build. Yes, yes. That for Python, other things you can, they will give you, but for Python, see, I'm just dropping SBC here. When I open that SBC, I think my screen is visible, right?
Yeah.
I'll go to the programming, then we have new, and I'll go for some project name, sample. Okay, then I go for, see, if you go for empty Python, that means they will not give anything. But for the safety purpose, I'll ask students, so because they are writing exam notes, I'll ask them to go down to this one, Blink Python. That means when I create this Blink Python, double click now, you can get a template, predefined template is there. That is actually helping you. The header files will come, definition of main function will come, the pin declaration will come, while function, everything is there, except if statement, everything is there. So they are actually giving some clue for you. You can just build the program based on this. No need to by heart anything.
Okay, this is for simulation, and for the real implementation, can we migrate this code there?
No, okay, you can take the code, but still that they will not, you will not get that template over there. You have to write the coding in the Raspberry Pi and all. No,
Yeah.
Cisco, we are using Raspberry Pi Cisco PL app launcher. I think that Cisco PL app software is there, but in writing the code there, you want to type. We can use that code now. Whatever codes you are doing, every code is available in internet free of course. Okay, you can just give the name of the, like I have told you, that group pi sensor. Okay, so whatever sensor you're using, just go to Google and type the code for group pi motion sensor. You will easily get the code also. You can just copy paste the code there. No need to write your own code. You'll get the code for every sensor.
Okay,
but you should know some basics of Python. Then only we can do that, because no, that indentation, that semicolon, all those things are there. No, that you should know. Basics.
Yeah. Can we go with some other language like C#, Java?
I think they are working, but we are using this one Python. But they are here itself. See, we can see different languages. If they are using JSP also, here we can go for JSP, all the other languages. But people basically nowadays, the updated one, they are using Python only, because that group pi sensors, that if I'm using group pi sensor, that sensors are written for Python programming only. But if you're in different sensor, you are using different sermons, you can go for some other coding. But by default, they're using Python coding.
Okay. And what cloud you suggested? Could you tell the name?
Thingspeak.com. I will just show here.
Yeah, this one. Is this exclusively for this kind of work, IoT stuff and all, or can we use this for other development like?
No, you can use it to any purpose you can use, but we are using for this one because the coding is easy for. That's why I'm using for.
Your Cisco technology, Cisco Academy, they support this one, or how did you select this?
No. This is not support by Cisco. This is an open platform. Actually, they are providing free accounts. Okay, so we can create 5 channels and 5 projects we can create using Thingspeak. That is nothing related to Cisco. So this is not related to simulation tool. This is the tool which we can use only in real device. When you are using the real board, Raspberry Pi, Group Pi, real board only, we can try Thingspeak. But in Packet Tracer, we cannot try this cloud. That is simulation. No, we cannot connect the simulation tool to real Thingspeak.
Yeah, means whatever you demonstrated, we can develop from this this cloud technology, right?
Yes, whatever you are doing now, whatever real projects you are doing, you can upload the data into cloud.
Okay, thank you.
Okay, sir.
Any other question?
I have a question.
Yeah, we have a question actually from here. Yeah, you proceed.
So I have seen the explanation. So I have a doubt like, so what will be the real implementation of this product? For example, if you are going to implement this product in the organization, okay, so what are the technical stack components which is required, and what will be given handy at the first, and what needs to be developed here?
Okay. So as I told you, we are having bachelor projects in our college. So what we are doing is IoT based projects along with AI. Okay. So in our college, we have robotic projects. Okay. So there, by using this IoT, we have that controller is there. This one, Raspberry Pi controller. Then we have that sensors, everything what we do. So real world, what we, as you told, in the real world, to run these sensors, all these devices, we need power, right? So what we do whenever we make a project, we will have the power bank. Okay, so that power bank will be providing this energy, the power for the sensors. Okay, and all will be given as a small packet, like it will be like one small which one I'll show you that board. Okay, like 1 minute. This one, Raspberry Pi 4. Okay, these are all small boards. So on top of this board, we will connect the sensors. Okay, so the controller, the sensor, everything will be put in a small packet, and we will be enclosing that packet, and we can give it as a project. When you go there, when you want to install a particular project there, just go there, connect into the which one that your power bank. You can easily run that. For example, like you are asking, how we can control the which one that detect the smoke detection in our campus, right? we have the smoke detection project, so we can take that project. Okay, then there will be that sensor. When you turn on the switch, right, the power is coming and the program is always running, and what happens, the smoke sensor will read it. Okay, so smoke sensor will read it, and automatically that alarm will be produced. So it will be a small packet like structure. You can easily connect every device in the Raspberry Pi, and you can run that project. Whatever be the project, you can run it. And we have that robot also told, so we have that in our college, one teacher, Dr. Venkat, has created a project. No, in that project, what happened, no, whenever someone entering the room, okay, that face detection, that attendance monitoring, everything is done by the IoT based that robot. Okay, that robot, we have already that machine learning algorithm. No, we have put the algorithm, and by using that program, they already have the records of all students and everyone. So whenever someone entering, no, that camera we already put in the robot, no, they will scan the picture and they will run the program, and they will turn on and they will make sure that the person is entering, that attendance is marked, everything is done. Nowadays in our college also, we are going to plan like that. Okay, like instead of manual taking attendance, no, we are going for this IoT based or AI based robotic attendance system. So we can implement this anywhere. I hope you got my point, right?
Yeah, I got it. Yeah.
Okay, thanks. So, Dr. Saju, any other
We
doubt?
can wind up this session, right? If no more question.
Okay, sir. Thanks.
Okay, thank you.
Shall we leave?
Wait. Subi, your turn. You are muted, Subi. You are muted.
Yes, so now we are about to wind up our session. And before winding up, I would like to extend our deep and a sense of appreciation to all our speakers for their elegant explanation. Even though the time is short enough for such a big topic, but they had covered up everything in this short time and had made everything clear to all the questions and also all the participants that had participated here. And so I would like to take this moment to express our immense appreciation and thank you, Rajesh and Dr. Briguram, to spare your valuable time as well as your knowledge with the Spiders platform. Thank you. And a wide round of applause to all our participants, those who are there in our office as well as on this Zoom meet. To spare your also the valuable times, and also I hope that you had made your skills improved and polished it to use it for your further growth and development to the CITES Academy. And so thank you all and have a good evening. Thank you.
Okay, thank you.
Thank you so much. Thank you. This mouse is not detecting.